Today I'm making a plasma cutter jig so I can cut huge steel discs like this. This is 3/8 thick and probably around 30 inches round. Stay tuned.
Alright, I'm going to go ahead and make a circle jig for my plasma cutter, and these are the parts I'm going to use. These are a couple of bearings that I got from Menards. Just a bearing. It looks like a cable would normally ride inside this bearing, but I'm going to repurpose it for the plasma cutter jig. Got two of these. I got a couple of brass plugs. Those are normally used in chillers to plug tubes. These were left over from a job, so I'm going to repurpose them. And a chunk of steel there. That's going to be the collar that my plasma cutter nozzle rides in. So I have a little boring action going on my lathe. I've got a Sheldon lathe I'll be doing some turning on. I might even knurl some knobs and stuff for the plasma cutter. It's not really necessary, but makes them look nicer for sure. So we'll get started. Okay, so first thing I got to do is bore a collar to go around this nozzle. This is the nozzle for my plasma cutter, and I'll be doing it right there. I have that piece of steel already chucked up in the lathe. It's already got a bore in it. I just need to resize it. Just something left over from another project, so figured I'd go ahead and use that since it's already got a nice hole already bored in it. Okay, I finished the boring process. I did a little step up there because this nozzle, so there's two different size bores in there. It has two flats. It has this one down here at the bottom, this one midway. So I kind of step bored it inside there so that it would accommodate both flats, because I want this to run smooth. I'll probably put a couple drops of oil in there whenever I'm using it, so it'll ride like a bearing without actually using a bearing. So that's the reason for that. But anyway, that should hold the nozzle pretty straight and flat and true, and go to the next step. All right, just have to part this collar off that we just bored out. Okay, here's the collar. Let me zoom out a little bit here. Here's the collar I just turned. As you can see, it spins nicely on the tip, so that should make a nice smooth round circle cut, I'm hoping, when it's done. So the original plan was to take this rod and weld it to the collar, but I changed my mind. I think I'm just going to drill and tap it in case I damage the collar in the future. I can just unscrew it and make a new collar and screw it back on. I guess you could just as easily weld it, but that's the way I'm going to do it for now. Okay, I decided to go ahead and thread quite a, I don't know, probably about 2 inches of this 1/4 inch rod, mainly because I don't want this to screw in not enough or too far. I was going to put a jam nut there, and then on either side of the bearing pulley, I'm going to put a 1/4 nut there, and also one at the other end. So, I mean, you could possibly screw it in too far, and if you do that, then this won't allow the nozzle to spin as you're turning it. So, and I want that to spin freely. I'll put like a little bit of penetrating oil, or I don't know, oil grease in there as I'm making a cut. And because if it screws in too far, then you're going to be into your collar, and then it's going to interfere with the nozzle. It's not going to allow it to spin freely. So that's the plan now. I'm going to go ahead and get I don't know if I have them here, if I'm going to have to run to the hardware, but I have to get a couple, 3, I guess, 1/4 nuts to put on that rod. I'm going to dig around here first and see if I can find some. So it turns out I did end up having to weld that collar on. There was not enough width in the wall of that tube to get enough thread started, so didn't feel real good about that, so I ended up welding it. But you can see it's gonna work pretty good, I think, going across the metal. There's actually a different nozzle, but the same machine. So it should hold the correct gap off the material, because mine's a non-contact high frequency start plasma cutter. It's an Eastwood. And anyway, I'll go on to the next step and hopefully have something working here soon. Okay, I have the piece of brass checked up in the lathe. Gonna turn this 1/4 inch diameter right here on this end. It's about, I don't know, about 1/2 inch right now, maybe more. Gonna turn it down to 1/4 inch because whenever I do my circle hole jig, I'm just gonna use a 1/4 inch pilot bit or drill bit to drill the hole, and then this is gonna ride inside the hole that I drill to do the circumference or diameter. Just gonna touch off here. Take it up to the shoulder and clean it up. reset our height. Looks like it's way off.
Real life, baby.
Yeah, wife noise. Okay, that's our knurled nut that we just made. And this rod's basically going to go through here. We're going to have a set screw going on and through the top of this to lock it down so we can adjust our length of diameter. So that's the plan. It'll go right through there. But the wife's calling and I'm going to have to put this on hold. But you guys get the idea. So I got our brass piece hooked up here in the chuck. I'm gonna go ahead and center drill it so we can drill and tap that at 1/4 for our locking screw. Back over at the milling machine, I'm actually drilling this out because I couldn't find the small key chuck to my Jacobs chuck for the the lathe, I mean. So switched over to the milling machine to drill this out so I can drill and tap it to 1/4. Okay, so this is what we have so far. We have the nozzle that goes in the collar here, got the bearing, and then we have the brass that I just turned on the lathe. That small section right here is going to go into a pilot hole whenever I drill it into the material. And what I have left to do now is just bore through the top of this brass for a set screw, so I can move this back and forth and clamp down on the rod itself. So anyway, we're supposed to go out to dinner, and I have to call it quits for the night. I don't know if you guys heard it earlier, but my wife said, "I thought you said you were only going to be 2 hours." So that's the plan. Okay, I have a piece of stainless that I'm going to use for the set screw. I'm going to knurl the top, and it's going to be down to 1/4 as far as the set screw going through the brass. Just thought that would look nice, a little piece of stainless with the brass. I'm going to do the knurling portion first, and I'm going to do a pretty decent amount. I'm going to probably go down to at least 1 inch. That way when I turn it around and turn the 1/4 portion of it, I won't have to have that much force exerting on the piece of stainless when I'm knurling it. So that's why I'm going to do the knurling first and do more than I actually need, and then I'll face it down to size after I'm done that, or put it on the bandsaw, cut it down, and then face it off after that. So okay, that's the stainless set screw that I'm getting ready to thread. Basically, I just disengage the spindle here on my lathe. Then I can freehand the chuck pretty easily to do all my threading. So basically I just spin the chuck by hand and give it a little feed with the tailstock. That gets it going, and then I just do the rest by hand. That keeps it nice and square. Okay, that's our finished locking assembly for setting the diameter. Got the little piece of brass here, the stainless set screw that locks down on the shaft, and as you can see, if I loosen it up, it allows us to change the diameter of the nozzle to the plasma torch. So that pretty much wraps up the project, other than trying it out, so that'll be next. Okay, here's what we got. This is the jig that I just made for cutting circles for my plasma cutter. Drilled the pilot hole there through the middle. I'm actually made this because I got an upcoming project that I'm going to use a little bit of metal and wood. For those that don't know, I run a sawmill, and I'm going to make a computer table combining the steel flange and either some walnut or some maple. I'm not sure yet, I haven't decided. But anyway, this is going to be part of that build, and I wanted a circle jig. I could have bought one, but I got all the tools to make one, so I like tinkering anyway, so I thought I'd just go ahead and build one. But anyway, we're going to go ahead and try it now. I had this hole drilled right there. That's what the center rides in. And like I said, that's adjustable. You have a little set screw that comes down and clamps down on this 1/4 inch rod. So we're going to give it a whirl, see what happens. You can see it made a pretty clean cut for the most part, all the way through. I did have to adjust my heat. I'm probably gonna have to go back over this other part. I had it set for 50 amps over here, and I think I was going too fast as well. And there I I kind of got out of line. I didn't notice my circle jig came out of the center hole. So now I've been holding it ever since, holding the center down. But, you know, ever since I corrected those problems, everything looks pretty clean. Nice, nice cuts through here. So I'm gonna go over that other part that has a slag on it and make sure that I'm holding that center pivot point down. As you can see, it worked pretty decent. I had to play with my air and my amperage. I did blow a breaker a couple times. Mine's a 60 amp plasma cutter, and this wall thickness is 1/2 inch thick. So it was working, and I'm not the best with the plasma cutter yet. I've only used it a handful of times. But there's that screw up I had when I when it came off the center of the axis where I wasn't holding it down. But anyway, I'm pretty happy with it. I'm sure it'll do a way better job on thinner metal. But like I said, this is going to be for a table that I'm making for a computer desk, I should say. And that'll be coming up soon in another video where I combine some either walnut or maple, I'm not really sure yet, and this metal. Alrighty. Thanks for watching, like and subscribe.